Hello, welcome back. Today we're going to discover where the derivative of the sine x function comes from. In this case, we're going to use the classical limit definition of any function, and then we're just going to stick in the sine function. A very good knowledge of trigonometry, is needed. Okay, let's go right to it. So right here, after applying the limit process into the sine function, we see that we have a sine x plus h minus sine x divided by h. Now the biggest problem here is that we have this term. We have a term inside the sine x. But if you remember from trigonometry, there's a simple formula which states sine alpha plus beta, which can be any two variables, equals sine alpha cosine beta plus sine beta cosine alpha. Now, we can actually use this formula to actually simplify this part. In other words, to break it up into smaller pieces so we can actually do something with it. So if we actually follow the formula, we can break up sine x plus h into the following. Sine x cosine h plus sine h cosine x. Now it's completely broken apart, and we can actually fill in the missing pieces here. I'm just rewriting the whole thing. Alright, looks much bigger, and you might think that we're even farther away from solving the problem. But let's continue. Let's gather common terms in the numerator. Well, we have one term here, two terms here, and the third term here. The only thing I see in common is this sine of x. So let's actually gather them together. Because it's addition, this can be here, anywhere. But now, because they have the same term, we can actually factor sine x out. So we have sine of x. We're left with cos of h. Remember, we factored out sine of x. Minus 1, because it's minus sine x. Plus, and then what do we have left over? Sine h cosine x. Alright, good. And we're just going to divide h, because now we have two terms. So this is divided by h, and this is divided by h. Alright, now, if you actually remember, the top is the same thing. All I did was just factor sine of x out. Okay, now we're actually going to use some very useful limit rules that we should know. In this case, cosine of any variable minus 1 divided by that variable as that variable approaches 0 always equals 0. So by applying the limit definition right there, this will turn to 0. 0 times sine of x is always going to be 0, whatever sine of x is. Alright, so we can forget about this term completely. Let's go to the second part. Cosine x divided by h, two different variables, we're clueless. But sine of h divided by h, as h goes to 0, this actually approaches 1. So as you can see it, we have 0 plus 1 times cosine x, which simplifies cosine of x. In other words, the derivative of sine of x, which was our original question, actually solves to cosine of x. Alright, now for the graphical understanding, we're going to graph what we were looking for, sine of x, and what we got for the derivative, cosine of x. And we're actually going to see how they relate to each other graphically. So I'm going to go ahead and graph this. So the first curve right here along my pen, that's sine of x. The one under is cosine of x. Alright, now one important thing to see is, okay, derivative, what does that mean? It means find a tangent line, or in other words, the slope at certain points. Well, let's look at some very important or obvious points. Let's see. At that point right there of sine of x, this is a horizontal line. So the derivative must be 0. What do we have there? If this function, cosine of x, is a derivative function, it will predict our slope at every point. In this case, the derivative is 0. Alright, let's test other points to make sure it's not just a coincidence. So here we have sine of x, remember, original sine of x. There's also a horizontal line here. And what do we have here? Another intersection at 0. That means cosine is 0 at this point. In other words, the slope is 0 at that point. So if you can actually see, cos of x successfully predicts the slope of sine of x. Till next time.